Hello, am I
Yes,
audible?
yes, sir, you are audible.
Okay. In last class, we have started vector. I'm just going through in brief, just 1 minute. First, we define what do you mean by physical quantity. So you will say all of measurable quantity is termed as physical quantity. Now, we may define physical quantity in two different ways depending upon their behavior. Let's say X is any physical quantity having two terms. One is numerical value and the other is its SI unit or unit in which this particular quantity will be measured. Suppose for distance, let's say 5 meter. So 5 is any numerical value and meter is unit in which distance is being measured. So it will have two terms, numerical value and unit. So numerical value and unit combinedly tells you nothing but magnitude only. So we can say X is a physical quantity which having only magnitude. Similarly, there is another quantity that is Y which having numerical value, unit, and some specified direction denoted by this angle. So we can say it having both magnitude as well as direction. So we can differentiate this physical quantity on the basis of only magnitude. So we can call it as scalar, and the other having both magnitude as well as direction. So it will be termed as vector quantity. Now, how we represent any vector? So we mainly represent any vector in two different terms. First is analytical representation, in which a vector may be represented by any arrow, in which we have two terms. One is length of arrow, which will define magnitude, and next is arrowhead, which will define its direction along this path. So this representation is termed as analytical representation. We may represent any vector in component form, or we can say Cartesian form, for which we first define what do we mean by unit vector. A vector which having unit magnitude and shows direction only is termed as unit vector. Now we may divide this unit vector into two different parts. One, a unit vector which shows direction along coordinate axes, that is x-axis, y-axis, z-axis. It will be termed as universal unit vector. So to define direction along x-axis, it will be represented by I cap. Similarly, along y-axis, it will be j cap. And to define direction along z-axis, it will be represented by k cap. So this unit vector is also termed as universal unit vector or unit vector to define direction along respective coordinate axes. There is another unit vector to define the direction of vector itself, or we can say along vector. So it will be vector divided by its magnitude. Is it clear till this part?
Yes, sir.
Yes, sir.
Krishna, do you have any doubt?
No, sir.
Okay. Now, we may represent on the basis of this unit vector, or we may transform coordinate system in vector form. Suppose you have A having coordinate x and y. So if we represent this A in terms of vector, we can say A having magnitude along x-axis as x, and to define its magnitude, it is going along x-axis, we multiply it by I cap. Similarly, to define magnitude and direction along y-axis, it will be y times j cap. So this transformation of any coordinate system in terms of I cap, j cap, k cap is termed as vector. Now, if you define A from origin, it will be represented by any arrow. And if you want to calculate its length, so for this triangle, we have base, perpendicular, and length of this arrow will be termed as hypotenuse. So using Pythagoras theorem, you will easily calculate its length, which will be termed as magnitude of that vector. So vector is nothing but representation of any Cartesian or coordinate system in terms of another representation. Likewise, related to direction, I'm giving you one example. If P is at 1, √3, find first vector P, second mod of vector P, third theta with respect to x-axis. Try to find everyone using the above concept. If I just check the calculation of second answer, Krishna, on solving, please send your answer to me in direct message.
Okay, sir.
Good. Good, Krishna. Good. Good. Alan, any problem while solving? Just see, we have x coordinate as 1 and y coordinate as √3. So vector P equals to x component times I cap. So it will be 1 I cap plus y component times j cap. So it will be like this. Next, if you want to calculate its magnitude, it will be root of x component square plus y component square. So it will be 1 plus √3 on squaring will be 3 root under, or it will be root under 4, which is equals to 2. Is it clear, Fawaz?
Yes, sir.
And the last, if you have to calculate its inclination with respect to x-axis using this part, this will be termed as perpendicular, which is nothing but y coordinate, and this is base as x coordinate. So tan theta equals to perpendicular over base. Perpendicular is √3, base is 1. So it will be √3 is equals to tan theta. So theta for which tan theta is √3, so it will be just 60 degrees. Alan, is it clear? Alan, written till this part? Okay. Now next is, how do you apply any operation to vector? So next is operation on vector. First is addition. Since we have two different ways of representation of vector, so we can add them in two different ways. First, for Cartesian form, suppose you have vector A, which having three components as axi cap, ayj cap, and azk cap. Similarly, vector B will have bxi cap, byj cap, and bzk cap. Now, if you want to add them, it will be A plus B equals to. Since by using principle of homogeneity, you will say only like term or only quantity which having same unit vector must be added or subtracted together. So we have I component as AX in first part and BX in second part. So it will be AX plus BX times I cap. Similarly, AY will be added with BY only, J cap, and AZ plus BZ times K cap. Using principle of homogeneity, which tells you if two quantity will be added or subtracted, it will be possible only if both quantity must be defining same term that will be in terms of vector, which will be from same direction. So it will be same component, x component with x component, y component with y component, and z component with z component as well. Now, if you want to calculate its magnitude, it will be a plus b mod, which is equals to root of x component, that is ax plus bx square, y component, ay plus by square, and z component, that will be az plus bz square. This is how we add any two vector in terms of Cartesian form, and then we define its magnitude. Is it clear?
Yes,
Fawaz?
sir.
Yes, sir.
Yes, sir.
Okay. Now I'm giving you one problem. If A is at -1, 2, and 1, B is at 3, 1, and -1, then find first vector A, second vector B, and third vector A minus vector B. Just write it down and try to simplify it. Good Krishna, good Ifra. Just see for this A, we have three components, X, Y, and Z. So A in terms of vector, it will be X component times I cap. So it will be -1 I cap. Y component times J cap, and Z component times K cap. Alan, just send me your answer. Good, Krishna. Ifra, there is little mistake in sign. Just check your calculation.
Okay, sir, checking.
Good, Fawaz. Similarly, you may write vector B as X component is 3 multiplied by I cap, Y component is 1 multiplied by J cap, and Z component is -1 multiplied by K cap. So this will be vector B. Now to find A minus B, put the value of A minus of I cap plus of 2J and plus of K cap minus vector B 3I cap plus J cap and minus of K cap. Just expand, it will be minus I cap plus 2J cap and plus K cap minus with this plus sign, it will be minus of 3I minus with this plus, it will be minus of J cap and minus minus plus of K cap. Now rearrange them. Minus I and minus 3I, it will be minus of 4I, 2 minus 1, so it will be 1 J cap, 1 plus 1, it will be 2 times of K cap. So this will be your A minus B. Alan, any doubt? Okay, just write it down.
Done, sir.
Fawaz, okay. Next, to define analytical way, I'm giving you some property of this vector. First is sliding of a vector. Suppose you have a vector along this direction, A. So if you move this vector along this path, along this path, or along this path, or this path. if length of this arrow is fixed and its orientation, which means its inclination with respect to x-axis is constant. Length from this point to this point is constant, and its inclination with respect to x-axis, that is theta, is constant. So we may slide any vector to any of these four different positions. So we'll say a vector may be displaced keeping magnitude and direction fixed. Is it clear?
Yes, sir.
Yes, sir.
Krishna, any doubt?
No, sir.
Next is, what would be the condition for equality of two vector? Equality of two vector. As every vector contains two terms, one is magnitude and other is direction. So if magnitude of first vector equals to magnitude of second vector, and direction is represented by any cap or unit vector of first equals to unit vector of second, then we can say vector A is equals to vector B. So what should be the minimum condition for equality of two vectors? That is, both magnitude as well as direction of them should be equal. So this is magnitude and this is direction. Just write it down till this part.
Done, sir.
Alan, any
Done,
doubt?
sir.
No, sir.
Okay. Next is how to define angle between any two vectors. Let's say one vector is along this direction, vector A, and the other is along this direction, vector B. Means if the head of two vectors coincides at the single point, these two vectors will be termed as co-terminal vector. Which means two vectors having same final point. Two vectors having same final point or ending point is termed as co-terminal vector. Similarly, if one vector is along this direction and the other is along this direction, which means two vectors which having same starting point or initial point, so it will be termed as co-initial vector. Two vector having same initial point or starting point. Is it clear till this part?
Yes, sir.
Ifra, any doubt?
No, sir.
Now we may define in this particular A and B as this angle as well as this angle. Similarly, in this second example, we may define angle between two vectors as this part and this part. So according to the rule, arrange two vectors to form co-initial vector or co-terminal vector, then smaller angle in between them will be termed as angle between two vectors. Is it clear? So first, arrange two vectors as co-initial or co-terminal. Then smaller angle in between them will be angle between two vectors. Fawaz, is it clear?
Yes, sir.
Okay.
Done, sir.
Done, sir.
Krishna, any doubt?
No, sir.
Okay. I'm giving you problem related to this. Find angle between two vectors. First is this is vector A and this is vector B. use the concept of sliding of a vector and try to slide any one of them to form co-initial vector or coterminal vector. Then try to find angle between two vectors. Ifra, just check the calculation for the first part.
Okay,
Yeah.
sir.
Krishna, just think again. Your first answer is wrong. Just see this part. We
That
have to
first will be
first,
70 degree.
no, just see in this definition, we have to arrange two vectors to form co-initial vector or co-terminal vector. Then the smaller angle in between them will be termed as angle between two vectors. So first try to make or arrange the two vectors to form co-initial vector or coterminal vector. Then try to find the smaller angle in between them. If I just send you an answer, what you had told. Good. Fawaz, any doubt?
Sir, what to do in this?
Just see in this second example, are these two vectors co-initial or coterminal?
Co-terminal.
So we have to find smaller angle in between them. As we know, for complete circle, total angle will be 360 degree. And we have one part as 330. So what will be this measurement?
32.
Is it? So which one is the smaller in between?
Sir, 30 degrees.
So theta will be 30 degree for this part. Now in this first example, what you can conclude about whether these two vectors are co-initial or coterminal? Are they? So you'll say
Sir,
no.
it's
No.
For co-initial vector, the starting point of them must be at same point. And for coterminal vector, the final point of them must be coinciding or terminating. So we may shift A along its own path like this. So it will form vector A along this path and vector this path. So this will be vector A and this will be vector B. As total angle from this point to this point will be 180 degree. And according to the given value, total angle from this point to this point is 250 degree. So if you subtract 180 degree from this part, you will get this angle. So it will be 70 degree. Is it clear, Krishna?
Yes, sir.
You may shift B to this direction as well and try to find this angle, as this vector A and this vector B will terminate at this point, so they will behave as coterminal vector. So again, to get this value, we would have to subtract this to the total angle. So it will be 70 degree, this part. Alan, is it clear how to calculate angle between any two vectors?
Sir, can you say that first part once again?
Okay. First, whenever you have to define angle between any two vectors, first try to arrange them to form co-initial vector or co-terminal vector. In this example, as given the question, this was vector A, and the inclination between A and B from this point to this point is 250 degree. So just see in this particular junction, there is one head and one tail. So we can't say these two vectors as co-initial vector or co-terminal vector. So try to shift any one of them so that they will form co-initial vector or co-terminal vector. Suppose I have shifted this A along its own path to form like this. This is vector B. If we shift A along this path to reach at this point, then initial point of them will be at same. Is it clear?
Yes, sir.
I have just shifted vector A along this path to reach at this point. Now, total angle for straight line from this point to this point will be 180 degree, and we have to calculate this part only. So how will you obtain this angle? Subtract total angle and this 180 degree. You will get this part as 70 degree. Now you may shift vector B as well, slightly downward to form like this. I have shifted vector B downward so that they will form co-terminal vector. Now the angle smaller in between them will be this part, and this may be calculated by subtracting this total and 180 degree. Is it clear now?
Yes, sir.
Fawaz, any doubt?
No, sir.
Okay. You all have
Sir, done.
okay. So next is how to add using analytical method. There are three different laws in this analytical method. First is triangle law. Let's say one of the vector is along this direction and the other is along this direction. Try to shift vector B so that tail of second vector will coincide on head of first vector. So it will be vector A along this path. If we shift vector B so that it will coincide on the head of first, so it will be like this. Now, this arrangement of vector is termed as consecutive vector, which means if second vector or tail of second vector coincide on head of first vector, or they will arrange in consecutive manner, these two vectors termed as consecutive vector. So the resultant will join from the tail of first vector to the head of second vector. That will be from this point to this point as vector R. So it will be A plus B. Now we may reverse this vector B along its own path like this. So on reversing direction, keeping its length to be same, it will become minus B. Now, if you again apply triangle law for this path, that is from the tail of first vector to the head of second vector, like this. So this will become R2 or resultant for these two. So it will be vector A minus vector B. Is it clear?
Yes, sir.
So in this triangle law, put the tail of second vector to the head of first, then resultant will join from tail of first to the head of second. So this arrangement is also termed as consecutive vector. So in this part, R1 will be A plus B and R2 is joining A and minus of B. So it will be A minus B. Alan, is it clear?
Yes, sir.
Okay.
Done, sir.
Done, sir.
Krishna, any doubt?
No, sir. Done, sir.
Alan, you have written? Okay. Next is parallelogram law. For this, try to arrange two vectors to form co-initial vector or co-terminal vector. Like this is your vector A, arrange vector B like this so that these two terms will behave as co-terminal, co-initial vector. Similarly, you may shift this vector A along this and vector B along this so that final point of these two vectors will be coinciding at this point. So they will behave as co-terminal vector. Now, just see in this particular geometrical figure, which is behaving nothing but a parallelogram. So the diagonal in between them will be termed as a resultant of these two vectors. So it will be this term. So for this parallelogram, arrange two vectors as co-initial or co-terminal. Then they will form parallelogram. So diagonal in between them will be resultant. So R is equals to A plus B. Just write it down till this part.
Done.
Done.
Done, sir.
Done, sir.
Okay. Next is if you have to add more than two vectors, then we'll use Polygon law. As we know, addition is nothing but binary operation, which means it will define for two terms at a time. Similarly, for this vector, if you have to add so many vectors, so first try to arrange them to form consecutive vector. Then start adding two at a time. So it will be first from this point to this point, this is vector A and this is vector B. So let's say this is R1. So it will be vector A plus vector B. Next, if you want to add from this point to this point, let it be R2 and this will be C. So R2 will be resultant of R1 and C. R1 we have calculated above as A plus B plus C. Next, if you join this term to this point, it will be R3. So R3 equals to R2 plus D if this is vector B. Now, if you put the value of R2 to be the A plus B, C, and D. So this is how we can extend this triangle law to define this parallelogram law. So in this part, arrange all vector to form consecutive vector, then resultant of all will join from the tail of first vector to the head of final vector. Arrange vectors as consecutive. Then resultant will join from tail of first to the head of last. Is it clear?
Yes, sir.
Yes, sir.
Okay.
Done, sir. Done.
Done, sir.
Okay. Now using these above concept, I'm defining you. I'm giving you two different terms. First is if this is vector A this is first and this is second. In second example, try to define which one will be resultant. Ifra, just tell
Yes.
me, in second example, which one will be resultant? Using the concept of triangle law.
Sir, B will be the resultant in second.
Okay. And in first,
Uh, Sir, I'm not able to find in first because
Okay. Krishna, do you have any idea?
Yes, sir. I think it is C.
In first example
Yes, sir.
and in second?
So it is B in the second, I think.
Okay. Fawaz, would you like to answer? Which one will be resultant in first and second? I'm giving you one concept, how you can relate resultant for any closed loop. Try to find a point which having one head or one tail. Suppose in this second example, this is a point which having two tail. This is a point which having two head, and this is a point which having head and tail combination. So if all vectors are not arranged in same manner, then find out a point or choose a point which having a head and tail, then opposite of that point will be resultant. So just remember, if all vectors are not arranged in same manner, but forming loop or closed loop, then choose a point having head, tail combination. Then vector opposite to it will be resultant. So in this part, B will be resultant of C and A. So if you use this concept in the first example, just say in the first example, all vectors are arranged in same manner. So if all vectors are arranged in same manner and forming closed loop, sum of all must be 0. So you can't find resultant in that part. So if all vectors are arranged in same manner, to form closed loop, then sum of all will be 0. It means A plus B plus C equals to 0. I will prove it. Just see, if you reverse vector B from its own path, so it will be like this. So this will be minus of B. And then now, if you point out a point which having a head or a tail combination, it will be, for this vector, it will be this part which contain a head and tail combination. So opposite of this will be minus B, which will behave as a resultant of them. So you'll say minus B equals to A plus B, A plus C. If you shift this minus b to right side, you will get 0 equals to a plus b plus c. So this is how we can prove sum of all vectors arranged in same manner and forming closed loop would be 0. Ifra, is it clear?
Yes. Yes, sir.
Okay. Fawaz, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
Done, sir.
Okay. Next is to find the magnitude of these resultant. Magnitude of resultant of two vector. Let's say one of the vector is along this direction, other is along this direction. So the resultant will join from this point to this point. Now we have to find magnitude of this resultant related to A and B. So magnitude of A from this point to this point, magnitude of vector B and resultant is from this point to this point. So if you draw perpendicular line to this path, inclination between two vector is theta, and resultant is inclined at some beta. and B and R will be at some angle alpha. This is A, this is B, C, and this is D. In triangle ABC, cos theta is equals to base over hypotenuse, so it will be BC over AC. AC is B, so it will be BC is equals to B times cos theta. Similarly, if you take sine theta, it will be perpendicular over hypotenuse. So AB equals to B times sine theta. Since I have to find R for which perpendicular is AB and base is BD, that's why I have calculated the value of AB and BC in this triangle ABC using theta and B. Is it clear?
Yes, sir.
Okay.
Sir.
Now this will be B times sine theta from this point to this point. And this is B times cos theta from this point to this point. Now, in triangle ABD, using Pythagoras theorem, we can say AD square is equals to AB square plus BD square. AD is R, so it will be R square. AB is B times sine theta whole square. BD is BC plus CD, so it will be B times cos theta plus A whole square. Now, if you expand it, you'll get B square sine square theta plus we have A plus B whole square. So it will be A square B square 2 times of A into B. Now, if we take out B square as common from both these two terms, you're left with sine square theta plus cos square theta plus A square plus 2AB cos theta. As we know, sine square theta plus cos square theta is 1. So you're left with B square plus A square plus 2AB cos theta equals to R square. Since we have to calculate magnitude of R, so move this square to the other side. So you will get A square B square 2AB cos theta root under is equals to magnitude of this resultant. Is it clear?
Yes, sir.
Yes, sir.
Similarly, we may define direction of resultant by taking this beta. First, write it down to this part.
Done, sir.
Alan, you have done?
Done, sir.
Okay. Now, if you want to calculate its direction of resultant, so it will be tan beta equals to perpendicular, that is AB, divided by base, that is BD. So if you put the values, you will get B times sine theta divided by A plus B times cos theta is equals to tan beta. Just write it down. Okay, let's stop here. In next class, I will define you some more problem related to this, and then will start product of vector. Okay.
Okay, sir.
Okay, sir.
Sir,
Okay then.
thank you, sir.
Thank you.
Thank you, sir.
Thank you.